Alright, in the last video, we set up some core combat features. We gave the AI the ability to move toward the player, updated collision presets for both characters, and added basic attack actions like punches and kicks. In this video, we're going to start shaping this into an actual fighting game. We'll set up a proper side view camera, lock movement to a single plane, improve spacing between fighters, and introduce core combat mechanics like guarding, knockback, and knockdowns. By the end of this, your combat system will feel much closer to a real fighting game. Let's start by switching to that classic side view camera you see in most fighting games. Right now, our setup works well for a third-person game, but not for a combat-focused experience. So first, go into your third-person character blueprint. Delete the camera component and anything attached to it. Then head over to the event graph and remove everything under the camera input section. Now we're going to create a dedicated camera system. Go to your Blueprints folder, right-click, select Blueprint Class, choose Actor, and name it BP_FightCam. Open it up, go to the Components panel, and add a camera component. Save it, then drag it into your level. Position it so it frames both the player and the AI. A quick tip here, you can pilot the camera to get the exact angle you want. Next, we need to tell the level to actually use this camera. Open the level blueprint, add an event Begin Play node, then drag your BP_FightCam from the outliner into the graph. From that reference, add Set View Target with Blend. If you don't see it, uncheck Context Sensitive. Set the target to Get Player Controller and connect everything to Begin Play. Hit play. Now the level uses your camera, but it's static. So if the fighters move, they'll leave the frame. Let's fix that. Open BP_FightCam again. In the event graph, use Event Tick. From there, get both characters using Get Actor of Class, one for the AI and one for the player. Get both of their locations, add them together, and divide by 2. This gives you the midpoint between them. Now plug that into Set Actor Location. To keep the camera offset, adjust the X value so it stays at a fixed distance. Now when you press play, the camera smoothly follows both fighters and keeps them centered. Next, let's lock movement so characters only move side to side. Open the player character blueprint. Select the character movement component. In the Details panel, enable Constrain to Plane and set the axis to X. Repeat the same steps for the AI character. Now movement is restricted, but your controls might feel backwards. Let's fix that. In the player blueprint event graph, find your movement logic. We're only going to use forward and backward movement. Take the X value from your input action and multiply it by -1. This flips the controls so they match the side view perspective. Now your character should move correctly. Right now, fighters can get too close to each other. Let's add a simple repelling force. In the player blueprint, on Event Tick, get the distance to the AI. If the distance is less than a set value, for example 100, we push the player slightly away. To do this, calculate the direction between both characters, normalize it, and apply it using Add Actor World Offset. Repeat the same logic for the AI. Now both fighters maintain proper spacing during combat. Previously, we manually added weapon tags to collision components. That works for small setups, but it doesn't scale. So let's automate it. In the player blueprint, create a macro called TagMacro. Add an input for a collision component. Inside the macro, Use setComponentTags to assign the weapon tag. Then create a second execution path to remove the tag using getComponentTags and removeIndex. Now, whenever an attack starts, you add the tag. When it ends, you remove it. This makes your system reusable and much cleaner. Apply the same logic to all attack flows into the AI blueprint as well. Now let's add guarding, one of the most important parts of any combat system. We're going to start with a variable that acts as a signal, not just a state. Create a Boolean variable called isActivatingAction. This variable is used to tell the AI, an attack is about to happen, prepare to react. Why this matters? We're not waiting for the hit to land. We're signaling the attack before it happens, so the AI has time to decide whether to block. Setting the variable. In your attack flow, right before playing the attack animation, set isActivatingAction to true. Then after the attack finishes, set it back to false, sending this data to the AI. Now we need to pass this information into the AI system. Go to your BT service, calculate combat. Just like we did with distance, we store this value in the blackboard. Use set blackboard value as bool. Name the key something like player is attacking. So now, isActivatingAction variable in player blueprint feeds into player is attacking variable in the blackboard, which is being used in the behavior tree. Open your behavior tree. Make sure your blackboard key is set correctly. Then go to your attack task. Now we add a decision. If player is attacking is true, then the AI plays a guard action. If false, then the AI continues with normal attacks. Adding guard for the player. Now let's give the player the same ability. Create an input action. For example, map it to G. Create a Boolean called isGuarding. When the player presses the guard key, set isGuarding to true. Play the guard animation. Add a delay to match the animation length, then set isGuarding back to false. Now both the player and AI can guard, but more importantly, the AI is reacting before the hit lands, which makes the combat feel much more responsive and intelligent. Eight, guard hit reactions. Next, we handle what happens when a guarded character is hit. Using the onComponentBegin overlap event, check if isGuarding is true. If it is, then play a guard hit animation. Then return to the guard stance. This adds feedback and makes blocking feel responsive. Before we move on, let's clean up our blueprint a bit. Right now, the hit logic is repeated in multiple places, which makes things harder to read and maintain. So instead of duplicating nodes everywhere, we're going to wrap that logic into a reusable macro. In your player blueprint, go to the My Blueprint panel. Under Macros, create a new one called HitMacro. Move all your hit-related logic into this macro. This includes things like applying damage, checking if the character is guarding, playing hit or guard animations, triggering knockback. Now, instead of rebuilding that logic every time, you just call HitMacro wherever a hit is detected. This keeps your blueprint clean and makes future updates much easier. Now let's give attacks some weight. Create a custom event called Apply Knockback. Get the direction between attacker and target, normalize it, and multiply it by a force variable. Then plug that into launch character. You can tweak the force value for different attacks to make some hits feel heavier than others. Right now, every attack, punch, kick, and so on, has its own chain of nodes. So let's simplify that. Create another macro and call it MontageMacro. This macro will handle playing the animation montage, enabling collision at the right time, applying tags using your TagMacro, disabling collision after the attack. Once that's set up, you can reuse the same structure for every attack. So instead of building each attack from scratch, you just plug in different animations and values. This is a big step toward making your system scalable, especially once you start adding more characters and weapons. Finally, let's add knockdowns. Because this involves multiple animations, we'll handle it in the animation blueprint. Add a knockdown animation, a get-up animation, and create two booleans, is knocked out, is getting up. In your character blueprint, trigger these based on impact force. For example, if the force is greater than a threshold like 700, then we trigger a knockdown. Then in your AI system, add a Blackboard variable for is knocked out. Prevent actions while knocked down. Resume behavior once recovered. If you notice animations snapping or sliding, that's a root motion issue. To fix it, enable root motion on the animation assets. Then in the animation blueprint, set root motion mode to root motion from everything. This ensures animations play from their correct positions. And that's it for this part. We now have a dynamic fight camera, proper side-to-side movement, spacing between fighters, guard and block mechanics, knockback and knockdowns. From here, we can start refining the combat feel even further. If you found this helpful, make sure to stick around for the next part.